Hello and welcome to day 5 of our sequences and series unit. Today we're going to be going over infinite geometric series, so infinite geometric sums, as well as some applications of geometric sequences and sums. So let's jump right into it with this little warm-up question. We have what is the first term, so we're trying to find a1 of a geometric series that has 10 terms. All right, so we're going to have n equals 10. Given that the common ratio, I always put an extra n there for some reason, and make it ration, whatever, is 0.5, and the sum is 511.5. So I'm going to be using the formula for the sum of a geometric series. So it's Sn equals a1, 1 minus r to the n over 1 minus r. So using this, I'm going to fill in the blanks, right? So I got the sum, 511.5 is equal to a1, what I'm trying to figure out, 1 minus 0.5 to the 10th, because there's 10 terms, 1 minus 0.5. So let's jump over to the calculator. I want to figure out what that, the big fraction is, right? So I'm going to do 1 minus 0.5 to the 10th power divided by 1 minus 0.5. And that's going to give me this weird number, right? So 1023 divided by 512. I'm just going to write that down, right? So I got 511.5 equals, I already forgot it, but really I did. Okay, 1023. 1023 over 512 times a1. And so I'm just going to, multiply by the reciprocal or divide by that, however you want to think about it. So I'm going to do 511.5, words are hard, divided by that thing that I just got there. All right, so I'm going to divide by the answer, and that's going to give me 256. So the first term in this sequence is 256. Ta-da! Math. All right. The sum of an infinite geometric series that has a first term a and a common ratio r is given by S infinity equals a1 divided by 1 minus r. So this is our last of the formulas that we need to memorize. You should know 2 for arithmetic, and now this is the third for geometric. And it gives us a little bit of things here that says, like, hey, it might not always work. So the absolute value of r has to be less than 1. And if we break that down, what it's really saying is that r needs to be somewhere between -1 and 1. Not equal to either, but somewhere in between it. And technically, I guess it could be 0, but like, if you have a common ratio of 0, that's like really dumb because all of your numbers are basically 0. So like, that doesn't happen. If your r value is bigger than 1, then there will be no sum. And this is very specifically talking about the infinite one, right? So when we're doing an infinite, wow, that just ruined everything. An infinite, you can't see it still, but whatever. So we're going to try to figure out if this exists, and if it does, what it will be. So find the sum of the infinite geometric series if it exists. So first thing I'm going to do is just check what r is. So for this one, r equals 0.8, because this is set up in our perfect geometric pattern here, right? a1 times r to the n minus 1. So I got that r is 0.8. That means that I will be able to do this, and I know it's infinite because I got the little infinity guy right there. So using that formula, S infinity equals a1, 5, divided by 1 minus 0.8. And I just type this into my calculator, and I get that this is going to be 25. Right? So if I add this sequence infinitely, it will equal 25. And the reason this happens is because as our r value is between -1 and 1, that means that we're always decreasing. It's always getting smaller and smaller and smaller, this value here. And so each term is going to get smaller and smaller and smaller and smaller and smaller and smaller. And eventually they're going to be so small that, like, we're talking about adding like 0.000000001, and then adding whatever the sum is so far. We're going to now add 0.00000000001 again, and so on. And eventually they're so small that they don't make any difference. And that's basically what's happening here. All right. So here we have another way of writing an infinite sum. So we have 2 plus 2/3 plus 2/9 plus 2/27 plus ... What we want to try to do is figure out what the r value is. So they told us that it's geometric, so we're pretty sure that it's geometric. And if I'm looking at this, I notice that the top always stays as 2, but the bottom is going up by 3, it looks like, right? So we're doing, like, if this was 2 over 1, I have a random mark that I just put there. 2 over 1, we're doing like 1 times 3, 3 times 9, 3 times 3 is 9, 9 times 3 is 27. So I think we're multiplying by 1/3 would be like what our rule would be, is 2 times 1/3 to the n minus 1. So if our r value is 1/3, then that is between -1 and 1. And so we can find the infinite sum here. So we're going to say the infinite sum is going to equal 2 over 1 minus 1/3. And we have a calculator, so you can just very carefully type this in your calculator, and you're going to get that the infinite sum would be 3. Alrighty, it is your turn. Try to find the sum of the infinite geometric series, and I just want to remind you that you need to first check what r is. All right, and I will be here when you are done. Hey, what up? Long time no see. Let's check this out. R. It is set up as a perfect thing. We have 1 times -3/4 to the k minus 1, so that's following our geometric pattern perfectly, and our r value is a -3/4, which is between -1 and 1. So I can find the infinite sum here. So my r value, my a1 value is 1, because there's nothing in front of the parentheses, so I can just put a 1 there. And then I'm doing 1 minus a -3/4. All right, and when I type this into the fancy calculator, I get 4/7. All right, now technically we don't need a calculator to do this, right? We could figure this out by hand if we really wanted to, but do you really want to? Probably not. All right, we got another infinite 1 here because we got the dot, 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 dot. And it looks like each time I'm multiplying by 2, and so my r value is going to be r equals 2, and that is not between -1 and 1. So this infinite sum will not exist, and that's because our r value is making the numbers bigger and bigger and bigger and bigger, and as we keep adding forever and ever and ever, it's just going to get bigger and bigger and bigger. So technically this would equal infinity, but since infinity is not really a number, we say that it doesn't actually exist. All right? Alrighty. We're going to do some of these working backwards type questions now. So we have, what is the common ratio of the infinite geometric series that has a sum of 8 and the first term is a1 equals 3? All right, so they told us it's an infinite sum, which means that it is going to follow the formula a1 over 1 minus r. If the sum is 8 and a1 is 3, well, then I have an equation I can solve. So I'm hoping by now that you have figured out that we can just do the little switcheroo here, right? When we have something on the bottom and one thing on the other side, we can just switch them. But officially what I'm doing is I'm multiplying it to the other side and then dividing by 8. And so now I just need to figure out what's going on with this stuff. So, I would do this as like 8 over 8 minus r equals 3/8. And so r is going to have to be 5/8. But again, you have a calculator, so just like subtract the 1 and multiply by a -1 to figure out what it is. Alrighty, your turn. So, same idea. I will be here when you're ready. Hey, how's it going? Good? Okay, cool. Hopefully you got this one right. A little preview, r equals 2/3. Did you get it? You totally did. I know you did. So, just using the formula, 3 equals 1 over 1 minus r. I'm going to get 1 minus r equals 1 over 3. So if I'm doing this without a calculator, I'm going to rewrite the 1 as 3 over 3, and I'm going to see, hey, r is going to have to equal 2/3. All right, there we go. All right, word problems, your favorite. We're going to start off with the easy one, which is this pendulum. So a pendulum is like the thing inside a grandfather clock that's just like swinging back and forth, right? Like it's like a giant ball and it has like a weight on the end and it just like swings back and forth. Hopefully you know what I'm talking about. If you don't, Google it. You'll figure it out. So pendulum that is released to swing freely. So that means like nothing's purposely slowing it down. It's just like swinging on its own accord. Travels 18 inches on its first swing. So you can see right here, I mean, this picture's not the greatest, but it goes 18, all right? On each successive swing, so each next swing, the pendulum travels 80% of the distance that it previously did. And right there, that 80, I wanted to highlight that. That 80%, that's telling us that r equals 0.8, all right? And then it says, what is the total distance? That's a pendulum swing. So that total distance right there, that is saying what is the infinite sum if we go forever and ever and ever. How much will this have actually traveled if we go forever? So first thing I want to do is just identify like what the formula is and what A1 are, what A1 is and what R is. Wow, that was really hard to say. I don't know why. Don't judge me. I mean, judge me a little bit, but not too much. First swing is 18. Common ratio is going to be 0.8 because we're decreasing by 0.8 each time, 80%. So I can find what the infinite sum is going to be, right? So S infinity equals A1, which is 18, over 1 minus 0.8. And in my fancy calculator, that's going to give me 90. And then I'm just going to say inches total because I know that this thing has traveled 90 inches total as it's sitting there swinging back and forth, back and forth, back and forth, back and forth. And then eventually it's barely even tell that it's moving, essentially. Okay? And so if we added up all of those little arc lengths there, we would end up getting 90 inches total. So I don't think that one is too bad. It's this one that's a little bit tricky because there's lots of ways to set it up. I actually would encourage you to pause the video and see if you can figure it out yourself. Because there's like literally 8 million ways of solving this way, and I'm going to only show you 2 of them. So why don't you pause the video, see if you can figure out what's going on here. You know, we have a rubber ball that's being dropped from a height of 8 feet, and then each time the ball hits the ground, it bounces to 75% of its previous height. And we want to find the total distance that the ball is traveling, okay? You can use the little diagram there to help you figure out why this one's a little bit different than the one we just did. So I'm really hoping that you thought about that because I think that it is good for you to think about things and see if you can figure it out. So what we can see here is the first time we drop it, it goes down 8, okay? Then it hits the ground and it bounces up to 75% of its previous height. So 75% of 8 is 6. So that means that it travels up 6 and then back down 6. And then when it bounces again, so it hit the ground, and it bounces up to another 75%, but now 6. So that's going to be that it bounces up 4.5, and then it bounces back down, not bounces, but it drops down to 4.5, and it keeps doing that over and over. So if we're looking at this as a sequence, it goes 8, and then 6, 6, 4.5, 4.5. The next one would be 3.375, 3.375, and so on. And we want to find this total distance, so that's going to be our infinite sum. And there's a couple ways that we could do this. So one way is you could just make a new, sequence pattern with this. But what I'm going to choose to do is option 1, I'm going to call this. All right, so option 1. This is my preferred way. I think this way makes the most sense in my brain. What I'm going to do is say, well, what's the infinite sum of this? I start at 8 and I do 1 minus 0.75. All right. And that's going to give me my infinite sums, but that's only just one part of it, right? Because each time it goes down and then it goes back up. So what I can do is just multiply this whole thing by 2. And now I'm taking into account the fact that each time it goes down and up, down and up, down and up. Except for one time, the very first time, it only goes down. So what I can do is just say, well, I'm going to subtract that 8 because I doubled it. But I didn't mean to double the first one. I don't want to double the first one. I want to double every other one after this. All right? So we have the infinite sum of just 8, times 0.75 to the n minus 1. If we were using that as our formula, that gives us our numbers. We're multiplying it by 2 because we're bouncing up and down. And then I'm subtracting the first one because it only goes down. It doesn't bounce up because we dropped it. That's option 1. All right? Option 2, which I think is just as good, but it does require you to do a little bit of math sometimes, is what we basically do is say, hey, the first bounce is 8. And then what I'm going to do is do double every other bounce after that. So I'm going to start with 6, which is really the second term, but that's the first one that bounces every single time. And so 6 and everyone after it is doubled because it bounces up and down and the 8 isn't. So it doesn't matter which way you do it. Either way, you plug it in your fancy calculator and you're going to end up that it's 56 feet total no matter which way you do this. All right. And again, there are like 800 ways of trying to figure this out. Whichever way makes sense in your brain, I think these are the 2 most common ways. So you got yourself a your turn here. We got a hot air balloon. rises 90 feet in its first minute of flight, and each succeeding minute it rises only 90% as far as it did the first, the previous minute. What is its final height of the balloon? So we're going forever. All right, so pause the video and have at it. Okay, welcome back. Oh my God, so long. You didn't even pause the video, did you? You didn't. It's okay. You don't need to lie to me. It's whatevs. I'm gonna be okay. Okay, I'm over it. Here's the first minute, 90, right? Next one is going to be 90% of that. So that's going to be 81, right? So this is going to be the second minute. Then we're going to get 72.9, and I'm just coming up with a sequence just to like get us to understand what's going on here. Then 65.61, and so on and so forth, right? For the third minute and the fourth minute. So eventually, it's going to stop rising any meaningful amount, right? If I just went like forever here. And so I'm going to use the infinite sum. So S infinity equals 90 was my first value. My R value is going to be 0.9, 90%. And I type that in the calculator, and what do you know? 900 feet. So that's how high this hot air balloon is going to go. What's like the air up there at 90 feet? You think that's like, you can still breathe that, right? Because like you go skiing, it's like way higher than that. I don't know what I'm talking about. No, just ignore me. You know what? Don't ignore me. Hit like and subscribe. And then, I'll check you out in the next video. All right. Peace.